Hello everyone, I am Bindushree, working as an assistant professor in the Department of Electronics and Communication Engineering at Institute of Aeronautical Engineering. So in this session, I will discuss about this multiplexer and demultiplexer. So multiplexer and demultiplexer is the combinational circuits. So this combinational circuit is depending on the combination circuit output is depending on the present inputs only. So in this combination circuits, we are having the encoders, decoders, multiplexer and demultiplexers are there. So today we'll discuss about this multiplexer. So in this multiplexer, it selects as an input. So we are getting the particular output. So here we are transmitting the data from the input lines. So that input lines are the several input lines. So in the multiplexer, we are having the multiple input lines. We are getting the single output line. So alternate name of the multiplexer is the MUX or the data selector. So why the multiplexer is a data selector, we'll discuss later. So before that one, so what is the demultiplexer? Just a basic introduction about this multiplexer and demultiplexer. So in the multiplexer, we are taking the multiple inputs and the single outputs. So coming to the digital demultiplexer, so it has the one input signal. It generates the many output lines. So that it means it will be distribute the data. So that's what demultiplexer is, a data distributor. So coming to the multiplexer, so in this multiplexer, we are selecting the input data. So that output will getting the only the one single output. So that's what that is the data selector. So multiplexer and their name is the MUX or the data selector. Demultiplexer is the DMUX or the data distributor. It's distributed the one input signal to the many output lines. So by using the multiplexer, we can communicating the data from the one to the many. So here we are having the multiplexer and data multiplexer is there. So in this communication purpose are the channels, we are using the multiplexer and the demultiplexer. So first one is in the multiplexer, we are taking the multiple input lines of the MUX. So we are getting the output data. So in this demultiplexer, so that output, that input will be given to the demultiplexer. So that is the input data. So here we are getting the original input signal. So this single input line will be the distributed to the many output lines. So that output lines we are getting the original input signal. So that is the multiple input signal. For example, the combinations of the MUX and the DMUX. So in the multiplexer, we are giving the multiple input signals. It transmitting the data, it communicating the data. So we are getting the single output line. Now we want to communicating this MUX and DMUX. So this output line is given to the demultiplexer input. So that is the output. Here we are connecting the output of that demultiplexer. So whatever the given input signal is the multiple input signals are there. So in the demultiplexer output also we are getting that particular signal. So that's what here I wrote the original input signals. So in this communication purpose, we are using the multiplexer and the demultiplexer. So already we discussed this one. So multiplexer is a combinational circuit. So in the combinational circuit, it is not depending on the any memories or any feedback loops. So it is depending on the only whatever the data, input data we are given. So it is depending on that particular input data only. So it is a combination circuit which have many data input, single output data. So in the multiplexer, it is not only depending on the input data. So it is depending on the selected inputs also. So any circuit, that circuit output is depending on the present input only. So coming to the multiplexer, so this multiplexer is depending on the selection lines also. So for n input lines, for example, we are taking the n input lines. So that selection lines are the log n base 2 selection lines. So that means we are giving the 2 power n input lines. 2 power n input lines, n selection lines are the required. So this multiplexer is also known as data and the selector. So it is a parallel to serial converter, many to one circuit or the universal logic circuits. So data selector, parallel to serial converter are the universal logic circuit. So it is mainly used to increase amount of the data that can be sent over the network with a certain amount of time and bandwidth. So this will be increasing the amount of that particular data. It can be sent over the network. So it is depending on the time and the bandwidth only. So for example, in this one, we are taking the 2x1 multiplexer. So here we are having the 2 power n into 1 multiplexer is there. So we are taking the some 2x1 multiplexer is there. 2x1 multiplexer is there. So here how many input lines are there? 2 input lines. How many output lines are there? Single output line. Okay, how many selector lines are there? So this is the 2 power 1. So 1 selector line. For example, n x 1 multiplexer is there. N is the input lines. 1 is the single output line. So the selected inputs are the 2 power n. Selected inputs are the 2 power n. Okay. For example, we are taking the 4x1 multiplexer. So single output line, 4 input lines. How many selected lines are there? 2 power n. So 2 power 2. 4 we are getting the based on this 2 power 2. So here the selected lines are the 2. So in that 4x1 multiplexer, 2 selected lines are there. 4 input lines are there and the single output line is there. So coming to this, for example, 16x1 multiplexer is there. 16x1 multiplexer is there. Single output line, 16 inputs, 2 power 4. So 4 input lines are there. So this is the based on the input lines we are getting the selected inputs. So this multiplexer is depending on the selected inputs only. We can select the data input as well as we are getting the output data. So this is the 2 power n is to 1 multiplexer. So here we are having the input data lines, output data lines, n selection lines. So this is the selected inputs. So these all are the input data lines. These all are the output data lines. So 2 power n means, so power n we are getting the selected inputs. Total 2 power n are the input lines, power n. So that n will be depending on this, n will be depending on that one. So that means 2 power n are the input lines, 1 is the output lines. So this n is the selected inputs. This n is the selected inputs. Okay. 2 power n cross 1. 2 power n cross 1. 2 power n are the inputs. Single output. This n is the selected line. Selected input. So based on the selected inputs, we are selecting the data. So based on the selected input and input data, we are getting the output data. Okay. This is the 2x1 multiplexer. So in this 2x1 multiplexer, 2 inputs. So the 2 inputs are assigned the A0 and A1. So this meaning is, what is the A0 and A1? So here we are taking the only the single variable. So that a variable is the A. 2 inputs, only we are taking the one input variable A0 and A1. So A is the one variable. So we are having the some difference of this each and every variable. So here we are having the A0, A1, A2, A3, A4 like this. So this is the 2 inputs A0 and A1. One selected input S0, output is the Y. Depending on the selected signal, the output is connected to the inputs. Depending on the selected signal, the output is connected to the inputs. This is the 2x1 multiplexer. A1 and A0 are the inputs. S is the selected input. Output is the Y. So this is the enable pin. This is the enable pin. Now only the single selected input is there. So that is the input. Okay. So here we are having the A1 and A0 are the data inputs. Enable pin is there. So when the enable pin is activating, when the enable pin is the 1, then the multiplexer circuit operation will be the started. When the enable pin is the 0, this circuit will not be working. Okay. So S0 is the input, output is the Y. So single input is there. So here the two combinations are possible combinations are the two only. So one is the 0, another is the 1. Okay. So single input. So first one is if the selected input is the 0. So first condition, if the selected input is the 0. If the selected input is the 0. So here the two inputs are there. Based on the selected inputs, we are selecting the input data. Based on the selected inputs, we are selected on the input. So if the selected input is a 0, we are selecting the one input data. If the selected input is the 1, we are selecting the another input data. So here the selected input is the 0. So here we are selecting the data is the A0. So for our convenience only, we are writing like this A0, A1, A2 like this. So if the selected input is the 0, so A0 will be the activating. So the output is the A0. If the selected input is the 1, so A1 will be the activating. The output is the A1. So this is the truth table of the 2x1 multiplexer. So S0 are having the 0 and 1. So Y is, if the S0 value is the 0, output Y is A0. If the S0 value is the 1, so A1 is, output is the Y. Now we are finding the Boolean function of this particular output. Okay, so Y equal to S0 bar A0 plus S0 into A1. So what is the S0 bar? So if that particular, in the truth table, that particular value is the 0. If the truth table, the particular value is the 0, then that is the S0 bar into A0 plus, so if that input is the 1, so that is the S0 into A1. So this is the Boolean expression of this 2x1 multiplexer. Based on this, we can draw the circuit of this one. Okay. So two input lines are there, I1 and I2. So that is the A1 and A2, two data inputs, A1 and A2. Selected input lines are the S and the one output line. So what is the equation of this one, ma? So Y equal to A0 S1 bar plus A1 S bar. So not the S and the S not, only the single S is there. So A1 S. Okay. So here how many gates are including the in this Boolean expression? How many gates are there? So one NOT gate is there, one OR gate is there. So another one is the AND gate is there. So now we want to draw the circuit for this Boolean expression. We want to the three gates. So that gates are the NOT gate, AND gate and the OR gate. Okay, first we are taking the inputs A0 and A1 and the S is also the one of the inputs. So A0, A1 and S is the input. So for this S, one is the normal S is there, another one is the S bar is there. So that's what here we are taking the, this S is connected to this NOT gate. So that is the S bar. That is the S bar. So first expression is A0 into S bar. So in this A0 into, so AND gate, for this AND gate inputs are the A0 and S bar. So that is the A0 into S bar. Next one is A1 into S. A1 into S. For this NAND gate, the inputs are the A1 and S. So AND gate one input is the A1, another input is the S. So this is the A1 into S. Now using the OR gate, so we are adding these two bits. So that bits are the A0 S bar plus A1 S. This is the construction of the 2x1 multiplexer. Next one is 4x1 multiplexer. So in this 4x1 multiplexer, so how many input lines are there? 4 input lines are there. Single output lines are there. So how many selected inputs are there? So depending on the N. So this N is the 2. So 2 selected inputs, 4 inputs are there, single output is there. Okay, so in this 4x1 multiplexer, I0, I1, I2, I3 are the inputs. So 4 inputs, 0, 1, 2, 3 are the 4 inputs. Either we can start the input data from the I1, I2, I3, I4 also. But here I will take the I0, I1, I2, I3 are the inputs. S1 and S0 are the selected input. So output is the Y. Okay, so depending on the selected inputs, so here we are selecting that input data. So if this data is the 0, 0, we are selecting the data input is 0. If this input is the 0, 1, so we are selecting the data is the I1. If the selected input is the 1, 0, if the selected input is the 1, 0, so then that is the I2. If the selected input is the 1, 1, that is the I3. So if the selected input is the 1, 1, so this is the I3. So the output is the I3. What does that mean, ma? So if Y equal to I3 is there, so if this data I3 value will be the 1, so that output is the 1 only. So if the I3 value is the 0, so it will be representing, it will be producing that output is the 0 only. Depending on the, depending on the selected inputs. So here we are selecting that particular input data lines. In that particular input data lines, either the 0 is there, 1 is there. So based on that one, it will be producing either 0 or 1. Okay. So now we can see we'll see the truth table of this one. So these all are the selected lines are there. S1 and S0 is there. So 2 input lines are there. So how many combinations are there? 4 combinations. So 0, 0, 0, 1, 1, 0 and 1, 1. If the selected inputs are the 0, 0, so the output I0 will be the equating. So if the selected input is the 0, 1, so I1 will be the producing the I1 value. So 1, 0 is there. So it is the I2. 1, 1 is there. It will be the I3. So now I want to write the equation for this Y value. So now I want to write the equation for this Y value. So first condition. What is the condition? S1 and S0 are the 0, 0. So if these selected inputs are the 0, 0, what we are using? Using the inverter. So Y equal to S1 bar, S0 bar, I0. So when the selected inputs are 0, 0, that is the I0. So S1 bar, S0 bar, I0. S1 bar, S0 bar, I0 plus next one is I1. So when the I1, we want to the I1 output data. So we are selecting the input lines are the 0, 1. So first one is the S is the S bar and the S0. So that is the S1 bar, S0. So here the why we are using the S0 only. So here the truth table, the data input is the 1. So that's what S1 bar, S0, I1 plus S1, S0 bar, I2 plus S1, S0, I3. This is the output line. So based on this Boolean expression, we can draw the circuit for this expression. So first one is S1. What are the input lines are there? S1, S0, I0, I1, I2, I3 are the input lines. So S1, S0, I0, I1, I2, I3 are the input lines. So now the expression is first one is S1 bar, S0 bar and I0. So S1 bar. So each and every input selected lines we are taking the one NOT gate S1 bar, S0 bar, I0. So S1 bar, S0 bar, I0. So using the one AND gate. Next one 0, 0, 1 is there. Next condition is S1 bar, S0, I1. So what is this meaning? So S1 bar is the 0, S0 is the 1. So S1 bar. So S1 bar. For this AND gate, one input is the S1 bar. So here the connection is there. So next one is the S0 is there. I1 is the data input. So connecting this AND gate. Next one is, so S1, S0 bar, I2. S1, S0 bar, I2. So S1, S0 bar, I2. So this is the another AND gate input lines. Next one is S1, S0, I3. So each and every AND gate, so the combinations of this each and every product term, so we are giving the sum, that is the OR gate. So each and every AND gate output is connected to this OR gate. So that is the output. This is a circuit construction of this 4x1 multiplexer. So based on this 8x1 multiplexer is there. So here also 8 inputs are there, single output is there. So how many data inputs, selected inputs are there? So depending on this particular n bit. So here the 8 cross 1 is the 2 power n cross 1. So how many selected lines are there? N selected lines. So if the n equal to 3, then only we are getting the 8 input lines. So that n equal to 3 input data. So the total 8 inputs are the 0 to 7. So that is the 0 to 7, that is the variable is the A0, A1, A2, A3, A4, A5, A6 and A7. So 3 selected inputs are there, S0, S1 and S2 are the selected inputs. Single output is there, that is the Y. So on the basis of the combination inputs line, so the selected inputs are the S0, S1, S2, the single output is there. So if the enable pin is the 1, then it will be start the working. If the enable pin is the 0, so it will not be the start this 1. So here the 3 input lines are there. So how many combinations are there? 7 combinations are there. So 0, 0, 0. So if the selected input is the 0, 0, 0, so it will be activating the A0. So 0, 0, 1, A1. So what does that mean? So if the A1 is, so when the selected input is 0, 0, 1, A1 will be the activating. So what is that meaning? So we are selecting the data input is A1. Based on the selected inputs, we are selecting the input data. So based on that input data, either the 0 is there, it will be producing the 0. So if in this A1 plus 1 is there, it will be producing the 1. So depending on that selected input, so we are selecting that particular input data. That input data, either the 0 is there, it will be producing the 0. 1 is there, 1. Okay. So this is the 0, 0, 1. So next one is 0, 1, 0. 0, 1, 0. So then A2 will be the activating. Next one is 0, 1, 1, A3. 1, 0, 0, A4. 1, 0, 1 is the A5. 1, 0, 1, 1, 0 is A6. 1, 1, 1 is the A7. Now write the equation for this one is Y equal to S2 bar, S1 bar, S0 bar. Either we are taking S0 bar, S1 bar, S2 bar. S2 bar A0 plus S0. So here the S0 is the 1. So that's why directly we are taking the S0, S1 bar, S2 bar A1 plus S0 bar, S1, S2 bar A2 plus S0, S1, S2 bar A3 plus S0 bar, S1 bar, S2 A4 plus S0, S1 bar, S2 A5 plus S0 bar, S1, S2 A6 plus S0, S1, S2 A7. So based on this Boolean expression, so here we are draw the circuit of this one. Okay, so each and every input we are having the zeros and ones are there. Based on that, here we are taking the NOT gate. So the first one is the S0. This output is the S0 bar. So here the S1 is there, S1 bar. S2 is there, S2 bar. Only 3 input lines are there, S0, S1, S2. Okay. So first combination S0 bar, S1 bar, S2 bar. So here total 8 product terms are there. So here we are taking the 8 AND gates. 3 input lines are there. So 3 input lines are there. The first condition S0 bar. So the input is the A0 data. Directly we are giving the input data A0. Okay, S0 bar, S1 bar, S2 bar. So this is the so 0 is there. So initially S0, S1, S2 are the 0, 0, 0. So directly we are giving the data is like this. So next get 0, 0, 1. 0, 0, 1. So here the 0, 0, 1. So this output is the 0. So next condition is, so this is the 0th one, 0 and the 1. Okay, next combination. So output of this AND gate is the 0. Based on this, here we are connecting the all the AND gates input data. So after that we are getting the OR gate. So each and every AND gate output is connected to this OR gate input. So next one is the implementation of the higher order multiplexer. Now we'll discussed the 2x1 multiplexer, 4x1 multiplexer, 8x1 multiplexer is there. So now I want to construct the 16x1 multiplexer. So if we are taking the 16x1 multiplexer, how many selected inputs are there? How many selected inputs are there? 16 selected inputs are there. Single output is there. So that one, so here we are getting the 4 selected inputs are there. Okay, so that's what. So here we are reducing that constructions, reducing that area of that particular space, and propagation, power dissipation also modes. So now we are reducing that one. So here we are using this 4x1 multiplexer and the 2x1 multiplexer ICs. So first one I want to construct the 8x1 multiplexer either using the 4x1 multiplexer and the 2x1 as well as 4x1 and 2x1 multiplexer. Up to this, what do you know about this multiplexer? So before going to implementing the higher order multiplexer, what do you know about this multiplexer? So if you are having the 8x1 multiplexer, 8 inputs are there. Okay, single output is there. 3 selected inputs are there. 3 selected inputs are there. So this is the 8x1 multiplexer. Now, so this is the overall this one. So either we can construct this one is I0 to I7, S0, S1, S2 are the selected inputs. So is the output. So now I want to construct the 8x1 multiplexer using the 4x1 and 2x1 multiplexer. So in this 4x1 multiplexer, how many data inputs are there? 4 data inputs are there. Single output is there. So 8x1 multiplexer, so 8 inputs are there. Single output is there. So 3 selected inputs in the single output. So now we want to construct the 4x1 multiplexer. Now we are constructing the 8x1 multiplexer based on the 4x1 and 2x1 multiplexer. So for the 4x1 multiplexer, so for this purpose, so here we are getting the 8 data inputs. Each 4x1 multiplexer produces 1 output. So we require a 2x1 multiplexer in a second stage by considering the outputs of first stage as inputs and to produce the final output. Okay, so in the first stage we are connecting the 4x1 multiplexer. So in this 4x1 multiplexer, how many inputs are there? 4 inputs are there. 4x1 multiplexer, how many inputs are there? 4 inputs are there. So 8x1 multiplexer, how many inputs are there? So second stage of this one, we are connecting to this 2x1 multiplexer. So now the construction of this one is, so if we are constructing the 8x1 multiplexer using the 4x1, we can take the 2 4x1 multiplexers. So each and every multiplexer we are having the 2 selected inputs S1, S0. So coming to the 4x1 multiplexer, through selected inputs are there S2, S1 and S0, S2, S1 and the S0. Okay, in the 4x1 multiplexer, 4 inputs are there. So coming to the 8x1 multiplexer, 8 inputs are there. So the selected inputs are the S1, S0. So for this 8x1 multiplexer, 3 selected lines are there. So based on this, first one, if you are taking the 4x1 multiplexer, how many inputs are there for the 4x1? So 4 inputs are there. So if you are taking the one more 4x1 multiplexer, how many inputs are there? How many inputs are there? 4. So here the 4 is there, here the 4 is there. Total 8 inputs are available. So this output is connected to this one. This output is connected to this 2x1 multiplexer and the single output. So now we are concentrating on the selected inputs only. So here 4 inputs are there, here 4 inputs are there, total 8 inputs we are getting single. So output of this 4 class 1 multiplexer, this output of this 4 1 multiplexer is connected to this 2 class 1 multiplexer. Then we are getting this one. So here only 8 inputs are there. So that's why here we are taking the 8 combinations. Okay, from the 0 to 7. 0, 0, 0, I0, I1, I2, I3, I4, I5, I6, I7. Okay. So 2 4 class 1 multiplexers. So first 4 class 1 multiplexer, how many inputs are there? I0 to I3 inputs are there. So second 4 class 1 multiplexer, I4 to I7 multiplexer is there. So output of this 4 class 1 multiplexer, output of this 4 class 1 multiplexer is connected to this 2 class 1 multiplexer. 2 class 1 multiplexer. S1 and S0 are the input lines. S1 and S0 are the input lines. So for this construction of this 8 class 1 multiplexer, we want to the 3 selected inputs are there. So first 2 selected inputs S0, S1 are connected to this 4 class 1 multiplexer. We want to construct the 4 class 1 multiplexer. How many selected inputs are there? 2 selected inputs are there. So first 4 class 1 multiplexer, 2 selected inputs are there. So next 4 class 1 multiplexer, 2 inputs are there. So now we are connecting this. Now we are connecting these two 4 class 1 multiplexer used S0 and S1 only. So now what about the S2? So in the second stage we are connecting the 2 class 1 multiplexer. Why we are connecting the 2 class 1 multiplexer in the second stage? So output of this first one is connected to the second one. 2 class 1 multiplexer one input, and the next 4 class 1 multiplexer is connected to the 2 class 1 multiplexer next input. So here the 2 inputs are there. So how many selected inputs are there? 2 power 1. So here we are left the S2 selected line. So that line will be connected to here. S2 is there. So this S2 is connected to this multiplexer. Sorry, multiplexer. This S2 is connected to this 2 class 1 multiplexer. So finally we are getting the output. So now we are connecting the 16 class 1 multiplexer. If we are connecting the 16 class 1 multiplexer, so we are using this 8 class 1 multiplexer. So in this 8 class 1 multiplexer, 8 inputs are there. So again we are connecting this one more 8 class 1 multiplexer. 2 8 class 1 multiplexers are there. First 8 is the input, second 8 is also input. Okay. So output of this one and output of this one is connected to this 2 class 1 multiplexer. Output of this one and the output of this one is connected to this 2 class 1. So then finally we are getting the output. So here 4 selected inputs are there. So we are constructing the 4 16 class 1 multiplexer. 4 selected lines are sufficient. So in this first 8 class 1 multiplexer, we are taking the input data is from the I0 to I7. So here the input data is I8 to I15. So 3 selected inputs are there, S0, S1 and the S2. So one more is there, that is the S3. So output of first 8 class 1 multiplexer is connected to this 2 class 1 multiplexer. Next output of this one is connected to this next multiplexer input. Okay. So this is the 2 class 1 multiplexer. So that is the output S3. That is the output S3. S0, S1, S2 are connected to these 2 8 class 1 multiplexer. So S3 is the 2 class 1 multiplexer. Output of this 8 class 1. Output of this 8 class 1 is connected to this 2 class 1 multiplexer. One more selected inputs we are giving. So this is the 16 class 1 multiplexer using the 8 class 1 multiplexer. So if you are constructing the 16 class 1 multiplexer using the 4 class 1, how can we are getting the connecting this one? So total, so first 4 class 1 multiplexer we are getting the 4 inputs. Again 4 class 1 multiplexer we are using the 4 inputs. Again 4 class 1 multiplexer we are using the 4 class 1 also 4. So total 16 is there. So now we are taking the 16 input 16 4 class inputs are 16 inputs are there. So but we are using the 2 4 class 1 multiplexers. 4 cross 1. So each and every multiplexer I0, I1, I2, I3. Next I4, I5, I6, I7, I4, I5, I6, I7, I8, I9, I10, I11, I12, I13, I14, I15. So each and every 4 cross 1 multiplexer. So here we are using the data is I0, I1, I2 and I3. Sorry. I0, I1, I2, I3, I4, I5, I6, I7, I8, I9, I10, I11, I12, I13, I14 and I15. So each and every 4 cross 1 multiplexer output is connected to this next multiplexer. So in this multiplexer input data is 4 cross 1. 4 cross 1 mixer. So here we are taking the input lines, but here we are taking the 2 more selector lines, S0 and the S1. So S0 and S1, S0 and S1. So here we are connecting like this, S1, S2, S0, S1, S2. So in this 4 cross 1 multiplexer, 4 inputs are there, single output. So one more selector line is there, that is the S4. Sorry, S3. S0, S1, S2 are the first 4 cross 1 multiplexer inputs. So the selector inputs are the S0 and S1. So one more is the S3. So this is the output. Based on this 4 cross 1 multiplexer, we are designing the 16 cross 1. Either 2 cross 1 multiplexer. So 13 4 cross 1 multiplexer, 13 2 cross 1 multiplexer we are taking. So multiplexer applications are already discussed. This one: communication systems, transmission network, telephone network, photo credits, or communication system, arithmetic and logic units, transmission from the computer system of satellites. So like this. So next multiplexer is the next topic is the demultiplexer. In this demultiplexer, we are having the single input line, 2 power n output lines. So this demultiplexer is also called the data selector. So in the multiplexer, single input is there, many output combination circuits are there. So the information is received from the single input lines and direct to the output line. The information is received from this single input lines and desired to the output line. So on the basis of this value of the selected inputs, so here the demultiplexer opposite to the multiplexer. Demultiplexer is also known as the data distributor. So exact opposite of the multiplexer is the demultiplexer. So here the 1 cross 2 demultiplexer is there, single input and the multiple output lines are there. So 2 multiple outputs are there, 1 selected input is there. So input signal A, selected input, and one is enable pin. So another one is the output of this one. So this is the 1 cross 2 demultiplexer. So this 1 cross 2, so inputs are the S0, outputs are the A1 and A0. If the selected input is the 0, so this is the 0 and A. So this is the given input data. It will be distributing that data. So here the input is the single input is there. So here we are having the 2 outputs are there. 2 outputs are there. So if the selected input is the 0, so if the selected input is the 0, so the input single input is there. So this input is activating. So it will be producing the A. So S0 equal to 1. So this is the A and this one is the 0. So this is the demultiplexer. So here the equation is for this Y0 equal to S0 bar A0. S0 bar A0 or A. So if the Y1 equal to S1 into A. Y1 equal to S0 into A. Y0 equal to S0 bar into A. So based on this, here we have drawn the circuit of this one. So one is single input is there, S is there, one more input is A is there. So this NOT gate output is connected to this one. So S0 bar is there, A is there. So this is the S0 bar, this is the A. So S0 bar A, Next one is S into A. S naught bar A plus S naught A. So this is the final expression of this 1 cross 2 demultiplexer. So based on this 1 cross 4 1 cross 4 demultiplexer, how many inputs are there? Single input is there. Single input. Single input is the 1 cross 4 demultiplexer. 1 is there. So how many inputs are there? 4 inputs are there. Total outputs are the Y0, Y1, Y2. Sorry, single input is there. Total outputs are the 4. Total outputs are the 4. So 2 selected inputs are there. So either 1 cross 4 or the 4 cross 1 multiplexer. So the data inputs are selecting here only 2 cross 1 multiplexer. So in this 1 cross 4 multiplexer, 2 selected inputs are there, 4 data inputs are there. So single input is there, 4 outputs are there. Okay, on the basis of combinational input which are present at the selected inputs S0 and S1. So this is the 1 cross 4 demultiplexer. S1 and S0 are the 2 inputs. So this is the Y3, Y2, Y1, Y0 are the outputs. Here the expression is, how can we write this expression? So for this Y3, for this Y0 equal to S1 bar, S2 bar, S2 bar, S1 bar, S0 bar, S2 and Y0. Sorry, here the 2 selector lines are there, S1 bar, S0 bar, Y0. So next one is Y1 equal to S1 bar, S0, Y1. Sorry, A0 and A1. Only single input is there. A. Next one Y2 is there, 1, 0, S1, S0 bar, A. Y3 is there, S1, S0, A. Like this, we are writing the expression of this one. So based on this expression, here we are writing the circuit diagram of, draw the circuit diagram of this one. So this is the S1 bar, S0 bar. So now, first AND gate Y3 is connected to this A input pin, A pin. Next one is the S1 and S0. Next Y2 is the A, S1 and the S0 bar. Next one is S1 bar, S0 and the A1. So this is the, similarly Y0 also same. This is the 1 cross 8 demultiplexer single. So how many demultiplexers we are taking? So single input is there, many selected inputs are there. So finally we are getting the outputs. So 1 is the single input, 8 is the output, 8 is the output. So how many selected lines are there? So here the n equal to 3, 2 power n equal to 8. So 3 selected inputs, S0, S1 and S2. So now write the expression for this one. So for the Y0 is there S0 bar, S1 bar, A. Okay, Y1 equal to S0 bar, S1 bar, S2 bar, A. So Y3 equal to S0 bar, S1, S2 bar, A. So Y4 equal to S0, S1, S2 bar, A. Y4 equal to S0 bar plus S1 plus S2 into A. Y5 equal to S0, S1 bar, S2 into A. Y6 equal to S0 bar, S1, S2, A. Y7 equal to S0, S1, S3 into A. So this is the truth table of this 1 cross 8 demultiplexer. 3 selected inputs are there. How many combinations are there? 0 to 7. First 0, 0, 0 is there. Y0 value will be the A. 1 is there, Y1, Y2 is there. Y2 is there. So for this Y3 and Y4, Y5, Y6 are there. So based on this one, so here the data input is stopping like here or increasing like here. So for this 0, 0, 1, Y1 will be the 1, 0, 1, 0, Y2. So 0, 1, 1, Y3 like this. So this is a 1x8 demultiplexer. So each and every demultiplexer we are having the S0 bar, S1 bar, S2 bar, A0. So S0 bar, S1 bar, S2 bar, A. Next y1 equal to A into y1 equal to A into S0 bar, S1 bar, S2. Next y3 equal to, if for example we are writing the equation for the y3. So first one, so if the equation is like this, 0, 1, 1 is there. So what is that meaning? S0 bar, S1 and S2 and the A. For example, we are writing the equation is 1, 1, 0. So S0, S1, S1, S0, S2 bar, Y5. Sorry, Y6. Y5 only. Why? Because here the 6 value is there like this. So next one, 1x8 demultiplexer using the 1x4 and the 1x2 demultiplexer. So here we are using this 2 1x4 multiplexer in the first stage, and the second stage we are connecting this 2 1 demultiplexer is there. So in this 1x4 multiplexer, 2 selected lines are there, 4 outputs and the single input. 1x2 multiplexer, here only the selection line is there. So here the 8 data outputs, we need 2 1x4 demultiplexer and the 1x2 demultiplexer and the 2 outputs. So this is the 1x4 demultiplexer. So we want to design the 1x8. So where we are getting the 8 outputs using the 1x4 and 1x4. So 4 outputs are there, 4 outputs are there. I2, I3, 1 using the 1 multiplexer, we are taking the data inputs. So single input is there. So 1x4 is like this. So here 1x2 demultiplexer is there. So first stage, so in the multiplexer we are taking the last stage of that multiplexer, we are taking the 2x1 multiplexer. So in the here we are taking the first stage of this 1x2 demultiplexer, we are taking the input. A is the one input, selected line is the one more input. So this output is connected to this 1x4 demultiplexer. So here we are having the 2 input lines are there. So these 2 inputs are dividing to this, each and every separate 1x4 multiplexer is there. So this one is connected to this 1x4 demultiplexer. This one is connected to this 1x4 demultiplexer. So the selected inputs are the S0 and S1. So this 1x2 demultiplexer output is connected to this 1x4. So here we are getting the values from the Y0 to Y3. So this output is connected to here. 1x4 demultiplexer is there. This output is connected to here. So here we are getting the 4 output lines. So total this 4 and this 4. Total 8 inputs lines are there. S0, S1 and S2 are the 3 input data. So applications of the demultiplexer is, it is connected a single source to multiple destination. So in this demultiplexer is also used in the communication systems. So it carry the multiple data like audio, video and other forms of data using the single line for transmission. Using a single line for transmission. So in this multiplexer, we want to transmitting or communicating the data, multiple selection lines are there. So here we are using the demultiplexer, here the single line for the data transmission. Thank you. In this session, I will discuss the multiplexer and demultiplexer of this particular combination circuit. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.